Hello, and welcome to Ocean Academe Calculus 12. Euler's method. Example. What is the value of y of 0.9 using Euler's method for the differentiation equation 3 dy over dx minus 15y squared equals cos x, where y of 0.3 equals 0.5, and using a step size of h equals 0.3? First, let me write this down. We've got 3 dy over dx minus 15y squared equals cos x. Now, what I want to do is isolate our dy over dx. So this will be dy over dx equals 1/3 cos x plus 5y squared. Now I want to set up a table where my columns are n and then step size and then yn, dy over dx, and change y, which is dy over dx multiplied by the change in x. Now our n, we're just going to develop these rows, so 0, 1, and 2. Our step size is 0.3, so that's 0.3, 0.6, and 0.9. Now our yn is 0.5. The dy over dx is this expression here. So we've got 1/3 cos, and where we see the x, we put in our step size, and where we see our y, we put our yn, so that's 0.5. And this works out to be 1.568. Now our change y is our dy over dx, so that's 1.568, and we're going to multiply that by our change x, which is our 0.3. So we get a value of 0.47053. Now we go on to our next row. So again, we've got 0.5 for our yn, but this time we have to add our value here. So that's plus 0.47053, and that equals 0.97. Now again, we have our dy over dx, so we have 1/3 cos, and this time we're putting in 0.6, plus 5 times 0.97 from here. That's squared. Putting that into our calculator, we get a value of 4.9796. Now we take that value, 4.9796, and we multiply it again by our change x, which is 0.3, and we get a value of 1.494. Now our next column. This time, we're taking our value here, our 0.97, and we're adding this value here, 1.494. Adding those together, we get approximately 2.46. And that's our answer.